Hello everyone. Welcome to the Syed School. Today, we will learn about EtherChannels and configuring them. What is EtherChannel? EtherChannel, also known as link aggregation, is a network technology that combines multiple physical Ethernet links into a single logical link. This provides several benefits. Increased bandwidth. By bundling multiple links, you effectively increase the available bandwidth between devices. This is particularly useful for high-bandwidth applications like server connections or data center traffic. Fault tolerance. If one of the physical links fails, the traffic can be automatically rerouted through the remaining links. This improves network reliability and prevents service disruptions. Consider this RSTP topology. RSTP creates one path between every switch and blocks the remaining link to prevent infinite loop. However, if any link between the switches fails, STP or RSTP algorithm will again come into picture, blocking the services for some time and again create a new path. What if we add multiple parallel links between the switches so that if one link fails, the other link will be still working? However, STP or RSTP will block the parallel links to avoid infinite loop. We can confirm from this picture that the STP or RSTP blocks the parallel links, creating just a single path between the switches. However, I do not want STP or RSTP process to start again if any of the working link fails. Here, EtherChannel comes into effect. We can add 1 to 16 ports of a switch into one EtherChannel, and the switch treats one EtherChannel as one port. Let's create an EtherChannel link between the switches by adding the ports to the EtherChannel. Like adding gigabit port 0 and 1 to EtherChannel 1 in the switch 1. Similarly, we need to create EtherChannels in every switch. We have created EtherChannels and added 2 ports per EtherChannel. Now, if one port link G0 of switch 1 fails, the G1 port link will continue working. So, no STP or RSTP after the link failure and no convergence time. We can add 8 to 16 ports per channel depending on the protocol. How to configure EtherChannel? There are 2 ways to configure EtherChannel. 1. Manual configuration. 2. Dynamic configuration. Dynamic configuration uses 2 protocols. 1. Cisco proprietary Port Aggregation Protocol, PAGP, supports up to 8 links. 2. IEEE Standard Link Aggregation Control Protocol, LACP, supports up to 16 link, 8 at a time. Manual and dynamic configuration commands. Manual command. Channel group, number, mode on, in the interface configuration mode. Dynamic commands. PAGP command. Channel group, number, mode desirable/auto. LACP command. Channel group, number, mode active/passive. While configuring dynamic EtherChannel, any one of the 2 switches mode must be desirable or active with respect to the 2 protocols. Desirable or active desires for EtherChannel connection. Auto or passive waits for an intimation to create EtherChannel link. If both the switches are auto or passive, then no EtherChannel link is created. Similarly, we must not combine manual and dynamic modes in the 2 switches. Let's look at this topology. We have 2 parallel links between the switches, however, STP or RSTP will block the parallel link and will make sure that there is just one link between the STP path. Let's go to the switch 1 CLI now. Let's look at the spanning tree in the enable mode. We can see that the switch treats every port as separate ports, and as this is a root switch, all the ports are in forwarding state. Let's go to the switch 2 now. We can see that 1 gigabit port is blocked by the STP or RSTP protocol here. So, one parallel link between switch 1 and 2 is blocked. Now, switch 3. We can see that 3 of 4 parallel link ports are blocked by the STP or RSTP. Now, let's bundle these parallel link using EtherChannel configuration. We will bundle 2 gigabit ports of switch 1 as EtherChannel 1. We will go to configuration mode and then to interface range configuration mode. We will use EtherChannel manual configuration command here to create EtherChannel or PortChannel 1. We see that EtherChannel 1 has been created. Now, we create EtherChannel 2 in switch 2. EtherChannel or PortChannel 2 is created. Now, we go to switch 3 and create EtherChannel 3 and 4 as switch 3 is connected to 2 switches. We add the ports 8 and 9 to PortChannel 3. PortChannel 3 is created. Now, we will exit interface 8 and 9 and will go into interface 10 and 11 to create EtherChannel 4. PortChannel 4 is created. In switch 1, we create channel group 5 using the ports 8 and 9 as switch 1 connects switch 3. Now, we will go to switch 2 to create channel group 6 using the fast Ethernet ports 10 and 11 as switch 2 connects switch 3. So, we have created all the ether channels as in the picture. Now, the switches must treat every ether channel as one port and create a path using EtherChannel. Let's confirm this using the spanning tree command in switches. Now, let's check the spanning tree in switch 1. We can see that port channel 1 and 5 are treated as one port and both are in forwarding state as this is the root switch. Now, we will see the same in switch 2. We see that port channel 2 is the root port and port channel 6 is the designated port. Now switch 3. We see that port channel 3 is the root port and port channel 4 is blocked to prevent the infinite loop. As we use 2 links per port channel, the network will continue to work even if one link fails and we do not wait for the convergence. Now, let's configure the ether channel dynamically. I will use PAGP command. Now, let's type this command to check the ether channel summary in enable mode. We are in switch 2. We see that this ether channel has 2 gigabit ports. Now, let's use another command. We can see the protocol used here. As this is a manual ether channel configuration, we do not see the protocol here. We can see the ports in this command too. To configure dynamically, I need to remove the manual configuration. I will remove EtherChannel 1 and 2 and configure them dynamically. We will spare the other manual configurations. This is the command to remove the ports from EtherChannel. I will execute this command in switch 1 for port channel 1 and in switch 2 for port channel 2. Let's make the port channel 2 again using the dynamic configuration command. I am using PAGP configuration here. Let's set this channel to auto, which implies that this channel will wait for an intimation before making an ether channel link between the 2 switches. After the port channel 2 is created, we see that the switch still treats both gigabit ports separately as ether channel link is not created. We need to configure the other switch 1 in this case as desirable to create the link. Let's execute the desirable command in switch 1 to create EtherChannel 1. Once this switch is set to desirable, EtherChannel link between the 2 switches is created and we can confirm it using show spanning tree command. We can see now in switch 2 that port channel link is created and we do not see gigabit ports as separate now.